So in today's lesson, we shall be looking at how we can write the canonical form for an hyperbolic equation. How we can write the canonical form for an hyperbolic equation. Remember, we are still on the same topic, solution to second order partial differential equation. Remember, in our previous lesson, we learned how to write the canonical form for a parabolic equation, and today we are looking at the other type of canonical form, and that's the hyperbolic equation. We also learned that a second order partial differential equation is said to be hyperbolic if the discriminant is greater than 0. And whenever you have the discriminant to be greater than 0, then it means you are going to have two distinct and different family of characteristics. Now, basically, this means that when you have, let's say, a quadratic equation and then you solve for the discriminant from the quadratic equation, and then you are getting the discriminant to be greater than 0, then you see that you are going to get two real and then different roots. And this is what this basically means. When the discriminant is greater than 0, you are going to get two real and then different roots for that particular equation. And since our discriminant is going to be greater than 0 for the hyperbolic equation, we are going to have two real and then distinct roots. You also know that the characteristic equation of a second order partial differential equation is given as this: dy dx is equal to what? B plus or minus the square root of b squared minus 4ac all over what? 2a. So when the discriminant is greater than 0, that means that we are going to have some sort of this form b plus or minus b squared 4ac all over 2a. So we are going to split this into two, into positive and then what? Negative. So this is going to give us the first solution, and this is also going to give us. So how do we write the canonical form for an hyperbolic equation? How do we write the canonical form for a hyperbolic equation? So indeed, I have written down some steps, and this step is going to guide us to write the canonical form for hyperbolic equation. The step is almost similar to the parabolic equation, except at this very point. I think point 2 that differs, but the rest are the same. You can write it down, and then it will guide you along whenever you want to write a canonical form for hyperbolic equation. So the first step is that check the classification of the PDE, and we can do that using the discriminant. Write the characteristics equation and solve for the characteristics variable and set them to xi and then eta. So this is the characteristics equation. We solve for the characteristics variable and then we set them to xi and then eta. So you're going to set this one to xi and then we set this one to eta once we are done solving for the characteristic variable. So we have the third one: transform the derivative by computing for uxx, uxy, and then uyy. And we know how we can compute for these second partial derivatives. Now the fourth says we are substitute the expression for uxx, uxy, and then uyy into the equation that was given. So after computing for uxx, uxy, uyy, you substitute them into the equation that was given. You simplify and then you obtain what? U xi eta. So it means that whenever we solve for the canonical form for a hyperbolic equation, what we are going to get what? U xi eta. U xi and U eta will vanish. This will vanish, this will also vanish. You will be left with what? U xi eta. Very, very easy. So let's look at our first example. So the first step says that check the classification of the PDE, and we can do that using what? The discriminant. So we know that the discriminant is giving us b squared minus 4ac. Our a is the coefficient of what? uxx, so we have 4, and then our b is the coefficient of uxy, that is 5, and then rc is the coefficient of what is uyy, and that is 1. So we are going to plug this into the discriminant to see what we are going to get. So we have b is what? 5, so we have 5 squared minus 4. Our a is what? 4. Our c is what? 1. We have 25 minus what? 16, right? And that gives us what? 9, right? Good. Now you can see that 9 is greater than 0. So you can see that this equation is what? A hyperbolic equation because the discriminant is greater than 0. Then we move on to the next step. The next step says what? Write the characteristics equation and solve for the characteristics variable and then set them to desire and then eta. So we are going to write the characteristics equation. So we know that the characteristics equation is given as dy dx is equal to b plus or minus. So we are just going to plug in our a, b, and c into the characteristics equation. dy dx is equal to, our b is what? Our b is 5. We have plus or minus square root of the discriminant we had what? 9. So we are not going to work it again. So we have 9 all over 2. Our a is what? 4. Let's continue from here. We have 5. Now since we are having plus or minus, we can split it into 2 because we are going to have 2 solutions. Okay, so we have plus, let's pick the positive first. Then we have 9 all over 2a, and then we can also have our dy dx is equal to 5 minus root of 9 all over what? Sorry, 2 times 4. That's going to give us 8, so we have 2 times 4. So we have our dy dx is equal to, this is giving us 5 plus root of 9 is what? 3 all over, this will give us 8. Then we have all our dy dx is equal to what? 5 minus what? 3 all over 8. So from here we can say that our dy dx is equal to, this is going to give us 8. 8 divided by 8 will give us what? 1. Then we have our dy dx here is equal to 5 minus 3 will give us 2. 2 over 8. That's going to give us what? 1 over 4. So we have 1 all over what? 4. So from here, we are going to integrate both sides, right? So that we solve for the characteristics variable. We are going to integrate both sides. So we have this and that. Then we have this and that. When we integrate y dx, we are going to get what? Y. Then we have integrating 1 with respect to x, we have what? X plus the constant c, which is the constant of integration. So from here, you can say that our c is equal to what? Y minus what? X. Now let's come to this side. When you integrate this as well, we are getting y, and this is also giving us 1 over 4x plus the constant of integration. So you can say that our c is equal to what? Y minus 1 over 4x. So once we have this, we set this one to desire. We set, because it says, the second step says that, and set them to desire and then eta. So we are going to set this one to desire. We have y minus x. Then we set this one to what? Eta. So we are going to have y minus 1 over 4x. So we are done with the second part, the second step. Now the fourth step is that transform the derivative by computing for uxx, uxy, uyy, and then uyy. So we are going to transform the derivatives. Okay, so the derivative is talking about this. We are going to transform them into the xi and then eta, xi and then eta. So in doing that, we are going to take the partial derivative of the function xi with respect to x and then y. So we have our xi x. We are differentiating the function xi with respect to x. So any y term becomes a constant, and whenever we differentiate a constant, we get 0. So this is giving us what, -1. And then we have xi y. Where we differentiate this function with respect to y, this x will give us 0. So we have 1 here. Then move on to eta x. So eta x2, we are going to differentiate this function with respect to x. Any y term become a constant and it gives us 0. This is going to give us what, -1/4. And then we have eta y. We differentiate this x term will go to 0. We are left with y. We differentiate y with respect to y. We get 1. Now once we have this, we first find, before we can find where is it, uxx, uxy, uyy, then we need to find ux, the first partial derivative, because these are second partial derivative. So we have to find the first partial derivative with respect to x and then respect to y. So we have our first one, which is ux, and we have learned in our previous lesson, we know how to find for ux, right? So we know that ux going through xi is giving us what? U xi x plus u eta x, and then uy, partial derivative with respect to y going through xi, we have u xi y plus u eta y. Very, very easy and then simple. Let's continue from this side. So we have xi x here, we have eta x here, we have xi y, and then eta y. So we are going to plug this and that into this equation to find ux and then uy. So when we do that, we have our ux will be equal to xi x is what? -1. So -1 times u xi will give us negative u xi. Eta x, where is eta x? This is eta x, right? So when we plug -1/4 into this, we are getting -1/4 u what? Eta. Then move on to uy. So uy, we have xi y. So xi y is what? 1. 1 times u xi will give us what? U xi. Then we have eta y is also 1. When we multiply by u eta, we have plus u eta. Now once we have this, we can proceed to find our uxx, the second partial derivative. So we have our uxx. Now in doing that, as I said in our previous lesson, we are going to use the diagram that I drew on the board. The last time we were looking at the parabolic equation. So the diagram is given as this. So this is the diagram that is going to help us find uxx, the second partial derivative with respect to x. So this is u xi and this is u eta. So to get an expression for u xi, we use this diagram. To get the expression for u eta, we use this diagram. So we have ux here. So this is ux. It is the same as this. So to get the second partial derivative, you can use its expression or its equation. So we are going to use minus u xi. Then we find the expression for what? U xi. This minus is here. So we find the expression for u xi. This is u xi. So how do you get the expression for u xi? So this is how we go about it. We have u xi already here. So u xi. So we have u xi. Then we move to the s column, xi x. We have another x here which is on u xi. So we have to look for that one as well. So with that one too, we move to u xi eta. So we have u xi eta. Then we have what? Eta x. So we are done with the expression for u Zaya. We have u eta here, so we have to find the expression for u eta as well. So we have plus that one too. We have a coefficient of -4, so we have to write it -1/4. Then we find the expression for u eta. This one, we find the expression for u eta, and we are going to use this diagram. So in doing that, we have this how we are going to read it: u eta Zaya. Then you write it u eta Zaya. Then move on to the x column because we are taking it with respect to what? X. Then we have what? Zaya x. We also have an x here, so we move in this column. U eta eta. U eta eta. Then we have what? Eta x. So we are done with it. Then once we have this, we just do some small algebra here, then we simplify. So this is going to give us minus u Zaya Zaya x. This is also giving us minus u Zaya eta x. This is also giving us -1/4 u Zaya eta Zaya x. Now we can write u eta Zaya as well, u Zaya eta, because we know that for continuous function, the order of differentiation doesn't matter. So we can write it in this one form. And then we have -1/4 u eta eta x. Now you know that Zaya x is what? From here, Zaya x is -1. So -1 times negative give us positive. So we'll be left with u Zaya Zaya. Then we also have eta x. Eta x is -1/4. When we multiply by -1, we are going to get +1/4 u Zaya eta. Then we have -1/4 u Zaya eta. Now Zaya x here, this Zaya x is also -1. So negative give us +1/4 u Zaya eta. Then the last one, eta x. Eta x is also 1/4, but we have negative here, so it's going to be 1/16 u eta eta. So from here, I think we can do some small algebra. We can add this together. So this is going to give us u Zaya Zaya. Then this is going to give us what? So when we add this together, we are going to get, I think, 2/4 u Zaya eta, and we can break it to get 1/2, right? So we have 1/2 u Zaya eta, and then we have plus 1/16 u eta eta. So we are done with uxx. We are done with the expression for what? Uxx. Now we move on to uxy. We have uxy in the equation, so we have to find uxy. So where do you continue? So we have uxy. So uxy, we have ux here. So we can make use of what? The equation for ux. So we are going to use this for ux. But we are going to take the second partial derivative with respect to y. We use the expression for ux, which is this one. Then we take the derivative with respect to y using the diagram here. So we have negative u Zaya. So we have negative, and then we find the expression for u Zaya, and then we take it with respect to y. So u Zaya, so this is u Zaya, and we are going to take it with respect to what? Y, not x anymore, but with respect to what? Y. So we have, this is u Zaya, we have u Zaya Zaya, so we have u Zaya Zaya, then move on to the y, Zaya y. We also have another y on the u Zaya. So we are going to go in this well form, u Zaya eta, then we have what? Eta y. So we are done with u Zaya. We move on to what? U eta. So with u eta, we have the coefficient 1/4. Then we find the expression for what? U eta with respect to what? Y. So with that one as well, we are going to use the diagram here. We are going to use this diagram. So we have u eta Zaya, u eta Zaya. Then we have Zaya y. Then we have Zaya y plus, we have another y here on u eta. So we have to come to this direction, u eta, u eta. Then we have what? Eta y. So once we have this, let's expand the bracket. So this is going to give us minus u Zaya y minus u Zaya eta y. And this is also giving us minus 1 over 4 u. We can write eta Zaya as what? Zaya eta. Then we have Zaya y. Then we have minus what? 1 over 4 multiplying this u eta y. Now we know that Zaya y is what? 1. So we are just going to plug in, and that's going to give us minus u Zaya. Eta y. Where is eta y? Eta y is also 1. So this is going to give us minus u Zaya eta. Then we have Zaya y again. Zaya y is also 1. So when we multiply, we have 1 over 4 u Zaya eta. Then we have eta y is also 1. So when we multiply, we are going to get 1 over 4 u eta. Can we do some algebra here because we have Zaya eta. We can do some small algebra, right? So we have minus u Zaya. This is going to give us minus 5 over 4 u Zaya eta. Then we have minus 1 over 4 u eta. So we also have the expression for what? Uxy. So let's write it. We have uxy. So the next one that we have to look for is what? Uyy. We look for expression for uyy. So uyy, we have uy here. So in taking the second partial derivative, we are going to make use of this equation to find uyy, right? Good. So uyy, we have u Zaya. So we have to look for the expression for u Zaya, and we have to come to this particular diagram. Remember, we are taking it with respect to y. We are taking it with respect to what? Y. So u Zaya, taking it with respect to y. So we have u Zaya y. So we have u Zaya y plus u Zaya eta y. U Zaya eta y. We have u eta here, so we have to find the expression for u eta. Coming to this diagram, this is u eta. So we have u eta Zaya y. U eta Zaya y. U eta y. So we are going to get u eta Zaya y plus u eta y from the two diagrams. So when we do some small simplification, we are going to get this one. There's no need to expand. Okay, so we just have to plug in our Zaya y. Our Zaya y is 1. So we are going to get u Zaya here. And then we have eta y. Eta y is 1. So this is going to give us plus u Zaya eta. We have eta y here. We have Zaya y. So Zaya y is 1. So we have plus u Zaya eta. And then what again? We have eta y. Eta y is 1. So this is giving us u eta. So from here we can add this together to get u Zaya plus 2u Zaya eta plus u eta. So you also have the expression for uyy. We have uyy. So the next step is that substitute the expression for u1y, uxy, and uxs into the equation that was given. So this is the equation that was given. So we are going to substitute wherever we see uxx, we are going to plug in this expression, and then wherever we see uxy here, we are going to plug in this expression, and then wherever we see uyy, which is here, we are going to plug in what this expression, and wherever we see ux is also here, we are going to plug in this expression, and we have uy here as well, so we are going to plug in this expression. So let's do just that. So the equation is 4uxs, so we have 4 uxs. What do we have? This is uxs, so we are going to write the whole of this. We are done with 4uxs. Now let's move on to the next one, which is 5uxy. So the coefficient is 5, and then xy. So this xy, we are going to plug in the whole of this. Then we move on to uyy. So uyy, we have, where is it? This. We are going to plug in the whole of this. Then we have ux. So ux, we have these equations. We are going to have minus u xi minus 1 over 4 u eta. Then we have the last one, which is this one, uy u xi plus u eta, and is equal to what? 0. So we have plugged in all of that. We are just going to do some small algebra. The rest is algebra. So this is going to give us what? 4 u xi. This is giving us plus 2 u xi eta. I mean, this time this, we are going to get this. Then we have plus, this will give us 1 over 4. 4 times this, it will give us 1 over 4 u eta. Then we have minus, when we expand the bracket to 5 times negative u xi, we are going to get negative 5 u xi. This times this, we are going to get 25 over 4 u xi eta. We have minus 5 over 4 u eta. So we are done with this expansion. Now let's move on to this side. We have plus u xi 2 u xi eta plus u eta. Now let's expand this. This is also giving us minus u xi minus 1 over 4 u eta plus u xi. U eta is equal to 0. So from here, we can do some groupings and then see if we can cancel out. 4 u xi, then we have 1 u xi. This is going to give us 5 u xi. And then we also have minus 5 u xi. Then we move on to u eta. We have 1 over 4 u eta. We have minus 5 over 4 u eta. And then we have, so this and that is going to give us 5 over 4 u eta. And then we have, where is it, minus 5 over 4 u eta. Then we move on to the xi eta. So 2 xi eta. We also have 25 over 4 xi eta. We also have another 2 xi eta. So we have 2 plus 2 give us 4 u xi eta minus what? 25 over 4 u xi eta. And when you do the algebra, you are going to get, I think, let's say 4. 1 into 4, 4. So we have 4, 4, 16. So 16 minus what? 25. And that's going to give us what? Minus 9 over 4. So we have minus 9 over 4 u Zaya Itai. Then we move on to, I think this and that will cancel. Okay. So this and that will give us 0. And then we have minus 1 over 4 u Itai plus u Itai. This and that will give us plus 3 over 4 u Itai is equal to 0. Good. So for me, you can see that this will cancel this. This will cancel this. So we are left with this simple equation, which is minus 9 over 4 u Zaya Itai plus 3 u Itai 3 over 4 u Itai is equal to 0. We are looking for u Zaya Itai, I mean this. So we can decide to send this side and then we do some small algebra here. So for me, we can write this as 3 over 4 u Itai is equal to 9 over 4 u Zaya Itai. We send this one to the right hand side. We are looking for u Zaya Itai. So let's divide both sides by 9 over 4. And this part is going to be what? 4 over 9. So that this will cancel this. So at the end, we have our u Zaya Itai is equal to this 4 cancel this 4. 3 into 9, we have 3. So we have our final answer to be 1 over 3 u Itai. 1 over 3 u Itai. So this becomes the canonical form. This was the canonical form. Very, very easy. So that's why I said that whenever we find the canonical form hyperbolic solution, we end up getting what? U Zaya Itai. The U Zaya Zaya, U Zaya Zaya, and U Itai Itai will vanish, and we'll be left with U Zaya Itai. Very, very easy and then simple.